Hi everyone, I'm LiJiaying from the Department of PIA. Today, I will talk about data visualization using R. And in this video, the slides contain three sections. The first is two systems for creating graphics in R, and the second one is types of graphs for visualization, and the third one is graphical parameters in ggplot2. Let's begin with the first section. And the first one is the R-based graphics package. This package provides a variety of functions to visualize data, and visualization helps you to know the distribution of one variable or the relationships among different variables. You can use the functions to draw different types of graphics like bar plot, pie chart, histogram, and etc. And the general form of the functions in graphics package is as follows. You should specify the function name, x, and y, and other parameters. The variable y is optional depending on the type of the graphs, and other parameters include the titles, axis, shape and color of the dots or lines, labels, and etc. The R-based graphics packs are suitable for the quick plots as commonly used when initializing the plots. But the graphics package allow you to customize almost all parameters, which is not so convenient to draw a fancy plot for presentation. And here are two examples for the graphics package. The first one is a box plot about the miles per gallon distribution by the auto type. And the second one is the scatter plot. It's about the relationship between R weight and miles per gallon. And we will show how to draw these two plots later in our demo process. And the second system is the ggplot2 package. ggplot2 is based on the grammar of graphics, the idea that you can build every graph from the same components, a data site, a coordinate system, and the geoms, which is the visual marks that represent data points. And the required components of the ggplot2 is ggplot and the geom function. And one geom function could add one layer to this graph. And this panel shows the template to build a graph. And after the ggplot, we can also use the ggsave function to save the last plot in the working directory. And the second section is the types of graphs for visualization. We introduced the different types of graphs based on the number of variables we plot. If we plot one variable, we want to show the data distribution of this variable. So if we have a discrete variable, we can use the bar plot like this one. And for a continuous variable, the possible layers can be area plot, dot plot, frequency polygon, and etc. And the density plot and histogram plot are two commonly used types of graphs. And if we need to plot two variables, if the x is discrete and y is continuous, we can use the following layers such as the box plot, violin plot, dot plot, jilter plot, and line plot, also the bar plot. Here's an example for the bar plot. This plot is from one of my published paper. In this paper, we want to decompose China's air pollution. During 2013 to 2017, China achieved air pollution reduction significantly, but it experienced a significant rebound since 2018. So we want to decompose the PM 2.5 concentrations rebound into the meteorological and anthropogenic factors for each city. So the X is each city and is discrete. This is the English name of the city. And the Y is the change and composition of PM 2.5 concentrations and is a continuous variable. The second type of plot is the scatter plot. When the two variables are both continuous, we can use the basic scatter plot to display the relationship of two variables. And we can still add other layers on this scatter plot. For example, the smooth line, the quantile line, and etc. The scatter plot and the smooth line are two commonly used plots in the academic writing. Here is also another example. This plot is also from the same paper. We proposed a claim that the anthropogenic contributions to the PM 2.5 rebound were correlated over space. More specifically, we suppose that if a city is much closer to Beijing, it will receive much more pressure from the central government to reduce PM 2.5 concentrations. So before the 2017, it would experience the more significant PM 2.5 reduction, but also experienced more significant PM 2.5 rebound after 2018. So the X is the distance to Beijing, and the Y is the change in PM 2.5 concentrations. When we plot two continuous variables, there is another type of plot, the trend plot. Here's another example. In China offered financial subsidies for the large utility-scale photovoltaic projects since 2013. We want to quantify the impact of the FIT, that is a type of financial subsidy for the renewable energy. So we want to quantify the impact of the FIT on the solar PV capacity. First, we need to describe the trend of FIT and the PV capacity by the resource zone. And the next one, we will talk about how to plot multiple variables. The first type of plot is maps. The X is the longitude and the Y is latitude. X could the value could be discrete and continuous. Here we use a map to visualize the annual change in PM 2.5 concentrations of each city. The green color indicate that the air quality of the city is much better than last year, but the orange color indicate that the air quality becomes much worse. And the second type of plot to displaying multiple variables is the heat map. It can display the relationship between, maybe in this plot, between 8 variables. This study used a machine learning approach to predict the probability of a household to adopt residential solar PV. Here, authors want to highlight the new method, XGBoost method, performs better than the traditional logistic model compared with original data. So this study used several household attributes to estimate the PV adoption probability. So the dependent variable is the predicted probability of 3 masses, And the independent variable are the attributes of the household, including the average of electricity bills, capacity factor, square footage, education levels, homeowner's age, and a number of the household people, as well as whether having kids at home or not. And in the third section, we will introduce the graphic parameters in ggplot2 and the required elements as we discussed before, including the data, coordinate system, and geofunctions. This information decide the basic structure of the plots, but we need further define additional parameters to customize the plots. The other parameters include the titles, colors, points, lines, axes, legend, theme, and background, as well as the text annotations. I have summarized the commonly used functions as well as the parameters values in this slides for your reference. Now I think we can shift to the RStudio. Okay, at first we can set the working directory, and then we start from the R-based graphics package, and the first one may be the box plot. First, we attach the empty cars data, and recode the cylinder and transmission data into factor. Here we can plot the box plot. This is the box plot. The x-axis is the auto type. Is the it's the combination of the transmission type and the cylinder type. And the y-axis is the miles per gallon, and it can show the distribution of miles per gallon based on the auto type. Now we will clear the environment. The second one is also the same case, but it's a scatter plot. It shows the relationship between the car weight and the miles per gallon. And we will add the LM fitted line. The LM fitted line, this one, and also the low S fitted line. Okay, the blue line indicate the low S smoother. And then we will introduce the plots in ggplot2 and several complicated plots. The first one is the bar plot. First, we load two data sites, as well as the library, the ggplot2 and deployer packages. First, we only plot the required elements in the ggplot2, the data, x and y, as well as the geom function. We can get a plot like this one. And now we compare this with our final version. You can see we may need to reverse the x and y axis and change the labels as well as titles of the legend and the maybe the titles of axis, as well as remove the background and the grid line. Also change the color, also add the geom points to this line, to this plot. Now, and here are the other functions to customize our plot. We run this block of function, this plot of code, and here is the final version of this plot. Now we can clear the environment and continue to the next plot, the scatter plot. This plot is combined. This plot combined two plot. Put these two plot in the same page. So we will start from the first one. We elaborate two packages for the ggplot2, and also load the scatter plot data. Before plotting, we want to know the correlationship between the distance to Beijing as well as the anthropogenic contributions to the PM 2.5 rebound, and summarize the results of the simple linear regression. Similarly, we first plot the required elements. We can get a plot like this one. It's quite different from the final version of our plot. We need to modify the plot and make it look more beautiful. And we will change the name of the Y title as well as the breaks of the X title, X axis, and also add the geom smooth line, and as well as the label for each city. And then we also want to add a line to help you to identify whether the PM 2.5 concentration increased or decreased compared with the previous year. And here we can get there's the plot. Okay, here we can get the top panel of this plot. And then following the similar method, we can plot the bottom panel. And then we want to use the LiJiaying function. Use the LiJiaying function to combine the plot 1 and plot 2. The number of the plot grid is 1, and we want them aligned in both horizontal and vertical direction. So here's the final version of the plot. Also, we removed the environment list. And next we will plot this trend plot. And this trend plot, X is year and Y is our dependent variable as well as the independent variable. But for this plot, I didn't use the ggplot to just use the basic R graphics package. And first, I will cite the adjustment date for the FIT levels, and set some attributes of the plot. This one is about this two plot will be displayed as 2 rows, 1 column, and the margin of the plot. And we first will plot the time and the capacity for one resource stolen. And we will get this one. And then we will add lines for another resource stolen. Also add LiJiaying for Also add LiJiaying for this part. And we can also add the vertical line to indicate the adjustment of the substage. Okay. Wait a minute. Okay. This is the top panel of this plot. And then we will add plot as a step plot. We need to plot each segment and plot each bracket and add the text annotation. Then we close the plot windows and remove the environmental list. For the multiple variables plot, first we will try the maps, spatial maps. We need to elaborate 3 packages: SF, our natural Earth, and our natural Earth data. And we need to set the theme of the plot. And we will use the data from the R natural Earth data and use the function NE countries. We can plot the world map. Okay, here is the world map. Use the ggplot as well as the geom_sf function. And then we can add title, subtitle, and X labels for this map. As you can see, the world map and the subtitle 241 countries, the longitude, latitude. We can also add colors based on one variable. For example, we want to show the population of each country. And also we can zoom in the area of our interest. For example, we can set the X limits and Y limits of the map. We can get this one, but we can further modify this map. For example, we can add the bar and scale bar as well as the north arrow. We need to elaborate the GG spatial package and use the annotation scale function to add the scale bar and the annotation north arrow to add the north arrow. Then we could also add country names or other names. First, we need to find the centroid of each polygon and find the longitude and latitude of this centroid and combine it with the world dataset. Now we can add the name of country as well as the Gulf of Mexico in this plot. We will use the geom text to add the country name and the annotate function to add the Gulf of Mexico. We could also modify this plot. Now, here we go, and we change the color for the polygons as well as the background, and also change the labels for the X and Y axis tickets. That's all about the maps, and the last one is the heat map. It's a little bit complicated. But I just want to show how to draw how to plot this heat map, how to plot this heat map by R code. First, we need to library for packages as well as the data sites, and we need to set some parameters as well as functions. And this function mainly build some border for certain cells. And first we will plot the left panel about the combination of different variables. The first variable is the, I don't know. Oh, okay. The first variable is the average of the bill. We can just show this one, maybe. We can get the variable average of the bill, and as well as highlight several cells. And now we will run this block of code, and we can see where's the plot? Okay, we can see the combination of 7 variables here, and we want to show the line number for the highlight cells. Now we can still add the row annotations. So also, okay. And now we can define the width and height of each cell in the right panel, as well as the cell function to highlight the certain cells. And we should first define the color of the heat map. And we can show this one is about the distribution of probability, distribution of the regional data. Something like this. And we need to combine 3 heat map actually. The heat map for data, for logistic method, as well as the new method, XGBoost method. And we will return the right panel. And now we need to draw the annotation panel as well as a heat map list panel. And this will set the gap between these 2 panels. And now we will get the final version of the plot. We remove the environmental list. The last section will simply show the different graphical parameters in ggplot2. We use some sample data sets in R and plot. Here's a box plot with no color, and also a scatter plot with no color. We want to change the color by group. and we can get the box plot, change the color based on the group, as well as the scatter plot. We want to change the color by the group cylinder, so we will change the color parameters to the cylinder. And now we can also change the color. Sorry. We can also change the color manually and get this one. Also use the color from our color brewer and use the palette dark 2. And the color will be this one. And we can all display all combination of colors. And we use the dark 2, but we can change the dark 2 to any one of the name. Then we can change the line type, line color, and line wise. For example, we can use the scale line type menu, color menu, and set menu to change the point size, as well as the line color, line type. And we can also change the legend position. Where's the plot? Okay, we can also change the legend position. Here the position is on the top, and then we can change the position by specifying the numeric vector. Here is the legend, and then we can also remove the legend by using the non value. And the last one is about the background. We can set the background. Here is the default version, the default background provided by R, and then we can change the background. This is the same gray, and this is the same BW. Please wait a second. Okay, and you can also try the different theme and choose the most suitable for you. And that's all about today's lecture. And thank you very much for your time.